Okay, this is assignment 2.1.11.1, part one of the infrared remote assignment. Basically, we're going to learn how to capture infrared signals from an infrared remote and use those in our, for our robot or Arduino and so forth. All right, now again, the IR remote, infrared remote, you've probably seen them before. If you ever have a television or a DVD player or something like that at home, you've seen an infrared remote. Again, they're typically have some numbers on them and then some other kinds of buttons and so forth. And then, of course, they do different things depending on which button you press. So they're actually not too difficult to understand. Basically, we're going to use infrared light because, like with the line follower, visible light is too much interference. So there's too many other places to that reflect light and capture the light comes in from the outside of the sunlight or from fluorescent lights and so forth. So anyway, that's why we use infrared light. Infrared light is a different wavelength and is something that's not going to get kind of washed out with some of the other places. So and basically again it helps if it's a dark or a bright room, doesn't matter. You can even, for example, bounce off infrared light off of the walls or the ceiling and so forth and actually still reach your sensor. All right, so basically the infrared remote though gives us lots of different IR signals to use to control our devices, and each button basically sends a unique infrared signal to the sensor. So basically this does give us lots of options for controlling different devices. Okay, now for our project we're going to start by learning all the signals that the IR remote can generate. And then basically what's also nice about this project is we don't need the breadboard for this one. We can hook this, you can hook up your infrared sensor basically directly to the Arduino, and we don't need to fiddle with anything else right now. Okay, so the parts for this assignment basically we're going to get together is just the Arduino, the IR remote, the IR sensor, and then 3 male to female jumper wires. Again, we have to use the male to female ones to connect to the sensor and then also to the Arduino. All right, so let's go ahead and get those parts. So we're going to go to components here. So we're going to look up IR, see what happens. How about remote? Let's see. Here we are. Here's the IR remote. So we get that. So we need an IR sensor though. IR sensor. Here we are. So an infrared sensor. All right. So those are the only 2 parts we need. Basically, we need the infrared sensor and then we need our remote. Now again, each pin of these is going to basically be connected to our Arduino here somehow. So if you just kind of hover over the different legs of the sensor, you can kind of figure out what goes where. Okay. Okay, so our out, so the the leg that's actually going to read the signal, that's going to go to digital pin 3 here on our Arduino board. So we're just going to connect up a wire to that. Connect that over there. Maybe line this up a little bit. All right, and then we're going to change that maybe to orange. All right, so the ground obviously goes over here to the ground. So I'm going to kind of run that all the way over here. Go up here, connect to the ground, make that one black for ground, and then the VCC is the voltage. So we're going to run that to our voltage here, our 5-volt pin on our Arduino board. Again, kind of line everything up nice and neat. All right, so basically that's it. So now we have everything connected, and we're ready to start coding. Okay, so now we're getting ready to code, but before we code, let's talk a little bit about libraries. Again, libraries are a great tool for coding because basically it allows us to use code from that other people basically have kind of figured out the details to, and therefore we don't have to kind of spend a lot of time and effort to do that coding for us. Again, coders, we tend to be lazy. And there's no real reason to have to, redo code that has already been done before. So that's where libraries come in. It basically allows us to kind of reuse code from someplace else instead of having to write our own all the time. And the other, the thing is that, for example, you can do your own libraries. For example, and again, we use LEDs a lot. It'd be nice if we had kind of an LED library, which would kind of do the basic kind of stuff that we do all the time when we have to code for an LED. If all that was kind of located in one central location, and we could just call that when we needed to use it and so forth. But basically that's what happens. So that's what a library is. Basically you can kind of think of them as a group of similar functions. You can kind of think of them as like the public library or the school library, which again has lots of books. And those books have lots of information so that you don't have to go out and find all that information yourself. You can just go there and you can you can reference that information and then, pull from that information and use it for your own thing. Okay. So again, that's kind of what libraries do for us. Now for us, we're going to be using the IR Remote library, so the infrared remote library. And the reason that we're doing that, and the big part of the thing with IR remotes, of course, is that there are lots of them. Okay, there are lots of IR remotes. Lots of different devices use IR remotes and so forth. So, so there's a lot of different possibilities, basically, and a lot of different kind of things that could be happening with them. So again, instead of having to kind of go and code every time you wanted to use an IR remote, we basically just use the library, that has all the code kind of for lots of different remotes already in it. So basically that's what we're going to do. So this is what the library looks like. So I've gone and downloaded it here for us as a HTML file, so you can kind of see what it looks like. But basically, it's just code. Basically, it's like code that you would write. So basically, they start off with comments here, like we normally do, and then the comments kind of explain what to expect here for different things. So basically, in this case, this is different remotes here. These are different remotes. So here's an NEC remote, a Sony remote, a Panasonic remote. And basically this just kind of explains if it's been, if it has the information to decode the signals from those remotes or not. So a lot of, here's all the ones they've already done. Here's a couple that haven't been written yet. But basically, yeah, so it's just kind of, letting your program know kind of what to expect here. And then again, it does some other kinds of functions and variables and all kinds of stuff. So, but basically, yeah, it's got, like I said, it's got all the code in here already, so we don't have to kind of go through all that and do our own. Don't have to code it ourselves, basically. So basically, it'll pull in the information for us, and then we just use that code in our program. So, all right, so that's what a library does for us. Now it's time to start coding, so we're going to comment first, of course, before we code. I'm going to start with some comments here. So first of all, explanation of what we're going to be doing. In this particular program, we're basically just going to be, do a study of how the remote works and what each button does. Okay, so we're not really going to do too much with the remote yet. We're going to learn a little bit about it first. So basically, we start by downloading and installing the library for the remote. So that's the first comment there. Then we set up our pin. We only need one pin here for the IR sensor. And then we also need some code from the library, basically, to help to set up the pin there for receiving a signal. So again, basically, we're going to be using some code from the library to help us for that. All right, then inside our void setup function, we're basically going to set up a serial monitor so that we can send our information to the serial monitor, our code and so forth, so we know what the signal is and how it's been received and so forth. And then we're going to start the receiver so that we can start getting information from the IR receiver for our IR remote. All right, then we're going to do some more. So then in the loop function, basically what we're going to do is we're going to turn on the IR sensor, get some data, or check to see if the IR sensor is getting some data. We've already turned it on. Don't forget there's two slashes here for this comment. I just missed one, it looks like. All right, so but basically the results are going to be in two different forms. Basically, we're going to have a 32-bit hexadecimal number, but we're also going to have a decimal number too. So basically, there's two different kinds of information here. We're going to collect both of those because we want to use both of those later in a program that we're going to be writing. So basically, we're going to print the results of the hexadecimal 32-bit number, and we're going to also print the results as a decimal number. So basically, that we get both of those both of that kind of information for later. Okay. All right. Then we receive the next value. We start listening for our next, the next button on the IR remote basically to be pressed, and then when it gets some data, then we print out the results for that one. So that's basically all our loop function is going to be doing. Okay, so let's review a little bit about what hexadecimal means. Again, hexadecimal is what we call base 16 numbering system, which means we have 16 different numbers. Since we run out of numbers after 9, we have to use letters for this system. So we have A through F to get to 16. Basically, that's what we're going to be using for your numbering system. So, for example, a number in hexadecimal like 3A, to convert that to a decimal number, so we can kind of figure out what that is. We're going to use powers of 16 to convert that to decimal numbers. So basically, we start here with 16 to the 0 power for the A part here. Now A stands for 10, so that's why we have that in parentheses here. So this is going to be 16. Anything to the 0 power is 1. So this is going to be 1 times 10. Basically, that means I counted to 10. So that's going to be 10. The 3 is going to be 16 to the first, so 16 basically. So 16 times 3 is going to be 48. All right, so we add those two numbers together, 48 and 10, and then our decimal number becomes 58. Okay, so pretty simple. All right, so again, with only two hexadecimal numbers, basically, we can represent any byte. So if you remember a byte, bytes are 8 ones and zeros in binary. Okay, so but in hexadecimal, I only need two hexadecimal numbers to represent that. So the maximum hexadecimal number that I can get, or a maximum that with two hexadecimal numbers, basically is 16 times 15 plus 15, or 256. So if you add that up again, you get 256, which again is a byte. So 0 to 256 is a byte. All right. Now, so an 8-bit hexadecimal number basically again is just two numbers. So hexadecimal numbers go from 00 then to FF. For a 8-bit, basically we're going to have 8 binary numbers. So 8 zeros to 8 ones. And in decimal, that goes from 0 to 255. Okay. So for 16-bit hexadecimal numbers, basically we're doubling the amount of information. So that's 16 zeros or 16 ones. Okay. That adds 2 more hexadecimal numbers to our numbering system. So that's 4 zeros and then 4 Fs here. But that gives us, in decimal numbers, that gives us anywhere from 0 to 1024. And finally, in a 32-bit hexadecimal system, again, we have 32 zeros or 32 ones in binary. That gives us 6 hexadecimal numbers. Okay, so 6 zeros to 6 Fs. And again, that gives us 0 to 2048 different decimal numbers. Okay, so now our remotes don't usually have 2048 different values. They don't have 2048 different, buttons on them. But basically, there's just so many different remotes and different types of IR, infrared remotes, basically, that having about 2048 different values for different buttons that you could possibly have on a remote kind of is probably a good number. And that's why we use 32-bit hexadecimal numbers to represent the values for when we press the numbers and what signal they send, basically. Okay, so now it's time to code. So basically, we're going to start by downloading our library for the remote. Again, we're going to use our include command here. So that uses the hashtag and the include command, and then you got to tell it what file you're going to be including from which library and so forth. So use greater than, less than signs, and put the name of the file here. So irremote.h is the actual name of that file. All right. Then we're going to set up the pin for the IR sensor. So we're going to call it the receive pin here. So we set an integer variable in receive pin, and we're going to set that equal to 3 to represent the digital pin 3 on our remote. The next thing we're going to do is we're going to use the code from the IR library now to help with the receive signal. So we're going to create an IR receive variable kind of thing here. It's not really a variable, but it's kind of a variable. But anyway, it's going to use this function and the receive pin variable that we created to let it know what pin to use, what a pin is going to be coming off of. So that's what this particular function here is going to do. Then we're going to use a different function here basically to create a variable called results, and that's going to store the information from the receive pin so we can use it in our program. So, all right, then we're going to set up our serial monitor inside the setup function. So inside the setup function, we'll set up the serial monitor. Again, do that. We've done that several times already, but basically serial begin and so forth. Then we're also going to turn on the receiver. So again, this is where the IR receive here again is going to be enabled, the IR in basically. So we're going to take this function here, this receive thing, and turn that on basically, so we can start receiving information from the receiver. Okay, now for the loop function, basically we're going to be using an if statement to check to see if we've received anything from the IR sensor, the infrared sensor, like a signal from the remote. So basically what we do is we decode the signal from the sensor, and we put that into a variable called results. And we use the ampersand symbol here basically because we're using it as part of an if statement. Because basically what we're going to do is if this is 0 or null, we call it too, then basically it's going to be false, but if there's something here, then it's going to be true. So again, for an if statement, of course, we just want to see if something's true or false. So that's why we're using this ampersand, because we're just checking to make sure that you're checking to see if there's anything there. So basically, if there's nothing there, then we just keep going and we just keep looping. But if we get something and we get a signal from the remote, basically, then we're going to do this next series of statements. All right. So again, remember everything inside the curly bracket for the if statement gets done. All right. So the first thing we're going to do is we're going to print the results as a hexadecimal 32-bit number. So we're going to send to our serial monitor the hexadecimal, the word hexadecimal with a colon, and then we're actually going to send the results, the value of the results that we get from this this function here, basically this return function. We're going to get the results, and then we're going to make that hex. So we put the comma, and then we put hex here, basically to change this number into a hexadecimal number. And then we're going to do the same thing for a decimal number here. So we're going to capture the results and basically just print out the decimal number, the decimal value too. And then that just gives us something to compare both of these two, to give you an idea about like kind of what each one looks like, and you know, kind of maybe why we can do it, or just that we can do it both ways basically. All right, so then when we're done capturing the information, we want to set the receiver back to listening. So we say resume, and then basically keep listening for the next value. All right. So that's it for the code. Yeah, don't forget your curly bracket for the if statement. Again, we have a curly bracket here. We're going to need a curly bracket at the end here. So don't forget to type that in. And then that's it for the loop statement. The loop statement is basically just this if statement here. All right, so again, put that into your code, check it and see, you know, run it into Virtual Design Studio. And see what happens. And basically what you're going to do is you're going to open your serial monitor and click on some buttons, and you should get some information inside that serial monitor showing different values basically for the different buttons. Okay, so here we are at the back at the virtual circuit, and I've put in my code here. So I've included the IR remote code, I've included the receive pin, you know, set up the receive pin, got the functions going for the IR remote, set up the serial monitor, get that going, and again our loop here basically, which is just one big if statement, to basically check to see if there's results and send that information to the serial monitor. Again, I got the curly brackets for my if statement in there, so just make sure you get all that stuff set up. All right, then you turn on your serial monitor here. Now I want to be able to see the whole remote, so I'm going to shrink this down a little bit, maybe shrink this down, move this up. All right, so I want to get the whole remote in here. So again, you might have to, you know, fiddle with it a little bit to get there. But anyway, I want to be able to see the serial monitor over here when we run our code. All right, so let's start the simulation. Again, if we have no errors, then we should be working. So here I can see it's running. All right, now when I press a button on my remote, I should get some signal over here. So let's press the button 1. So there we go. So I get my hexadecimal number. and I get my decimal number that corresponds to that too. All right, so that's for the number 1. So if I press it again, I should get the same thing. So yeah, see, I get the same information here. So if I press 2, I should get a different number. So you can kind of see here I got a different hexadecimal number and I got a different decimal number. All right, let's do the up arrow here. So again, if I press that, then I get something different. So any of the buttons now that I press on the remote, I'll get a different thing. All right, so that's what you're going to do for your assignment here, though. You're going to capture all the different information here in a spreadsheet, a Google spreadsheet, basically, for each one of the buttons. So you write down, in one column, you're going to put what the button is. So yeah, so again, basically, you're going to create a sheet, a Google Sheets here for each one of the buttons. You're going to write down in one column what the button is. Okay, so this is like the power button. Here's the volume up button, the function stop button, and so forth. So put each one of the buttons in one column. All right, in another column, you're going to put in what the hexadecimal signal is, what the hexadecimal number is that corresponds to pressing that button. And then in a third column, you're going to put in what the decimal number is for that. Okay, so go ahead and do that. You're going to capture all that information into a spreadsheet. And the reason we do that, just to let you know too, the reason we do that is because we want to each remote is different. Each remote sends different signals. They may be, similar hexadecimal numbers, but maybe they're not exactly the same. So, for example, whatever 1 is here, maybe, that's what the hexadecimal number is on a different remote for the up button. So anyway, but the point here is that you want to kind of capture all the information for your remote so that you know what to use when you go back to do any kind of programming for your circuits and so forth using your remote. Okay, so you want to capture all that information first, get all that data. All right, go ahead and get started.